friends, today I'm going to solve LeetCode problem number 530, minimum absolute difference in BST. So here we are given a root of a binary search tree and we need to return the minimum absolute difference between the values of any two different nodes in the tree. Okay, so let's look at this example here. So what do we have? We have a tree which is a binary search tree, and we know in a binary search tree all the values to its left child nodes are less than the node, and all the values towards the right child node are greater than the node, right? Let's see at this example. So we have a value 4 at this given node, and all the left child nodes, which are the left child nodes, these, right? And all of these nodes have value less than 4, and these have value greater than 4. Now what does this question ask for? Minimum absolute difference, right? So when are we gonna get a minimum difference? Let's look at this example once again. So minimum difference would be calculated if we take two values which are close together in our uh, numeric sequence, right? So here if I take a value 4 and a value 2, like what would the difference be? It is 2, right? But the more closer value to 4 is 3. So if we take the difference with 4 and 3, we get a value 1, right? So 3 is more closer to 4, so that is what we need to do. We need to find the difference between the closest values. Now if you know, in binary search tree, if we perform InOrder traversal, the values in that tree will be sorted. So what does InOrder traversal mean? It means that we traverse left first, and then we traverse the node, and then we traverse the right of the node. Okay, so left and then the node itself and the right. So now let's look at this example once again. So we start from our root node, and now we are traversing to its left. So let's move to its left. So we are going to its left. Now we have this node and we are now recursively doing it. So for this subtree, now we are going to perform the same thing again. So we traverse towards its left again. So now for this subtree, from this node I am traversing to its left, and where do I reach is 1. If I traverse to its left more, then I get a value null, right? So that is what when I stop, and then once I stop, I have now the value. I now take the value of this node. Okay, so I'm just like using an array. I insert the value of this node at this point, and now I try to move towards its right. And since I do not have a value, I just stop right there and then I go back. Now while I'm going back, what did I do? I am going back from the left node, right? So while I'm coming from the left node of to the node itself, at this point, now I again insert into my array. So I insert this value 2 to my array. Next I move towards its right. So now the right of this node is equals to 3. If I try to go to its left, it's empty, right? So when I try to go its left, I found empty. I return back and then I reach the same node, which is 3, and at that point I insert 3 value. Now I try to go its right, and when I try to go its right, it's empty again. So what I do is, now since it is a recursive operation, it just goes back to the point where the call was made from. And since the call was made from 2 where we were traversing to 3, since this call is complete, the call stack is complete for this one, now we move to its calling node. So we have now completed traversing the left tree of this node 4. So what we do is, now we insert the node 4 into our array. So as you could see, like 4 is coming after 3, right? So it's 1, 2, 3 and 4, and then next would be 6. So if you move in the sequence left node and right, this is what we will get. Now what are we doing is, since we have all of them in a sequence, now we could just take a difference between the two adjacent nodes, right? So when I take a difference between 1 and 2, it's 1, 2 and 3 is also 1, 3 and 4 is also 1, 4 and 6 is 2. So among all of the differences that we found, the minimum is equals to 1, right? So that is what our answer will be, and that is what we are going to return. So here in this case, what we did is we performed an in order traversal, and we used an array to store each of our elements of the node. Okay, so that is what in order traversal basically is. It gives us a sorted array. Right now, let's see how we could find the minimum without having to create this array. Okay, in this case, if we're creating an array, we are traversing over each of the node, right? So that is still O of n. So traversal is O of n because we are traversing over each of the node, and also like creating an array is still O of n because it is of length n and we are traversing over each of them. So time complexity is basically O of n. And talking about space complexity, since we are traversing, we are using a stack, so space complexity is also O of n during our traversal, and this array also consumes an O of n space complexity. So overall space complexity and time complexity both are O of n. Now let's just try to solve it without creating this array. Okay, it would still be O of n space complexity because we are still traversing over our tree using an in-order traversal. So that would be a recursive call which would store our recursive call into the stack, and that consumes some space. So that is why we have space complexity of O of n. But let's just try to just optimize it a little bit. Maybe it would, like, the recruiter or the interviewer could ask you like how could you do it in a much better way. So this is how you could solve it in a much better way. So what we do is we do this thing, right? We traverse in order way. So we start from our root node, we traverse towards its left, for this node also we go towards its left. So now we have reached the leftmost point, and while we traverse to its left there is nothing. So now we have reached this node. So now since we have reached this position, the middle position, in this case what we'll do is we are going to um, create a variable. Actually, we are going to create a global variable, previous variable, and this previous variable will keep track of the value before the node. Okay, so like in our earlier case we had 1 2 3 4 and 6, right? So the previous will be the value 1 for node 2, and previous will be equals to 2 for node 3, and so on. So since we previous now is equals to 1, so our previous will be equals to 1 because we are at this node at this point. And now we are going to also calculate the difference. Okay, so before reaching this point, okay, before assigning the previous value, we will calculate the difference. So initially we do not have any values, so our minimum difference we will assign it as infinity value. And now while we take a difference between infinity and 1, the absolute value is equals to the minimum value is equals to 1 infinity, right? And next, once we have calculated the minimum value, now we assign our previous value as this node, and then next we try to move to the right of that node. While we go to the right, we know that the right of 1 is empty, so we return back to the calling node, and then since we have completed all the calls for this node, we now go back to its calling parent, which is equals to 2. Now like our previous is still equals to 1. So what happens is we have now come back from our left node, and now we have reached this middle portion. So here we are actually doing our calculation of finding our minimum. So now we find our minimum by taking the previous value and subtracting it with our current value. So our current value at this node is 2 and previous value is 1. So when we take a difference, the value is equals to 1, right? And since 1 is less than infinity, we update the value of minimum. And now our previous is equals to now current node. Now we update the value of previous node, and then we move to the right of that previous node of this node, so which is equals to 3. And for 3 also, we are again now going to traverse towards its left. Since we are traversing towards its left, it's empty, so we come back to itself, and then now we perform our calculation here. And to perform the calculation, we take the difference between 3, the current node, and the previous node. The current node is 3 and the previous value is equals to 2, so the difference would be 1, and we already have the value 1, right? So now we next try to move towards the right, and since there is no right node, we just go back to its calling parent, which is 2. And since we have done all of the recursive calls, we just like go back to this, the calling parent of this subtree. Okay, so that we have now performed the left recursion here, traverse towards the left of this node. Now we perform calculation for this node. Okay, yeah, we also need to update this value with 3 because we are at this node. We perform the calculation and then we update. Okay, I just forgot that. After updating, now we have been done with this one, we move to its parent, and now we perform the calculation. Okay, and while we are performing the calculation, we calculate the minimum value, right? And since previous is equals to 3 already, the minimum value we get is equals to 1 already, so we already have the value. So after we have done with the calculation, we try to go to its right, and before going to its right, we also find the minimum. We found the minimum, we update the previous with its current node. Now we move to the right, our value at the right is 6, and when we try to go to its left, it's empty, so we now move back to the node itself, and then we try to calculate the minimum. The previous value is 4 and the current is 6, so when we take the difference, it's 2, and 2 is greater than a minimum, so we do not update it, and then we change it to 6, the current node, and then we try to traverse right, it's null, so we then return back to our calling function, and then finally we are done with all our recursive calls, and the final value at our minimum is equals to 1, so that is what we return. So this is how we could do it if we are not using an array. So I'll just write the code where we do not use the array. So let us just start. So we need a previous value, so let us just define it as infinity, or we could just define it as negative infinity. So I'm going to define it as negative infinity, and a minimum value is equals to infinity initially, and we are going to perform an InOrder traversal. So let's create an InOrder function, and this function takes the value of the current node, that is the current node. Now we need to perform a check, that is if the node is not present, then if the node is null, then we return, right? Like you saw when we try to traverse towards its left, there is no left node, so that is when we return to the calling parent. And if the node is present, then what do? We try to go towards its left first, right? So node left, okay, not if, in order, we go to its left, and then next we calculate the minimum value and assign the previous value, right? So now min value is equals to math minimum of our min value and the difference between the current node and the previous node. Current node, the value of the current node will always be greater than the value of the previous node. Why? Because previous node is the value before our current node, right? And since it is a sequential in order and it's always ordered in an ascending order, in an increasing order, so it will always be greater. The current node value will always be greater than the previous node value, and this will always be positive, so we don't have to take an absolute of that one. Now we have calculated our minimum. Let's calculate our previous. So now our previous will be equals to the value at our given node, and then we traverse towards the left, right. Okay, now we are done with our traversal. Now let's call our function by passing our root node and then return the value of minimum. Okay, now let's try to run our code and see if it works. Awesome, let's submit this. Great. So as I already told, the time complexity is O of n and space complexity also is O of n. Okay, I'm just quickly going to show you like how we could do it using an array. So all we need is, we do not need this previous, we need to create an empty array where we are going to push the values. So we do not need any of these. All we are going to do here is push the value of the node at this position. And now after we have been done that, what we do is, now we have to find the minimum among all of these values in this array, right? So I'm just going to, we can use so here we are just going to use a for loop. Okay, it's important, right? And now if okay, equals to starting from 1 is less than root length I plus plus. Okay, and we check root at index I minus root at index I minus 1 if this is greater than mean. If this is less than our mean value, then we update our mean value equals to this value. Okay, and then finally return our mean value. Okay, let's run our code. Oh no, it didn't work. Okay, so comparing it with the previous value, this is the current value and this is the previous value. I need to value. Oh, it's an array. I'm so sorry. Awesome, let's submit this now. Great. So this is how we could solve this problem. Let me know in the comments down below what do you think about my solution, and if there is any problem that you want me to solve in LeetCode, do let me know. Okay, hope you have a wonderful rest of your day. Thank you.